I started the video a little late. First question, multiply the whole thing by 3 would give you this. Nice, simple, easy question. Yes, Daniel?
Would it always be a vertical dilation for that question?
It would have to be, yes.
Okay.
If it was a horizontal dilation, you wouldn't be given this in standard form. It would be written in a different form, and you would multiply what's in the parentheses. But I don't think, we never did that. We always had a vertical dilation, which is multiply the whole thing, or a vertical translation, which would have been just changing that last number. But it'll be this question. I don't know. I don't even think you'll see this question. I think it's a little too easy, but we'll see. All right, so 24, we just got through doing stuff with this. This is given a rectangular point, so it says right there, which of the following is the equivalent expression of a complex number in polar coordinates. So you don't really have to remember what complex is. Complex just means it has an I in it. If you look at the formats, it is already telling you need R and theta, and it gets plugged in, okay? So what we do is we use our X and Y to find R and theta. So what we would do is say, what quadrant is this guy in? Well, that would be in quadrant 2, right? Left 5, up 5 would give me this point right here. Left 5, up 5. Okay? And then we just use Pythagorean theorem to find C, R, absolute value of Z. We've called it so many things, okay? But this is going to give us R by doing Pythagorean theorem. So 5 squared is 25. Negative 5 squared is also 25, which gets you 50. Square root. And if for some reason you got to this part and you had a hard time doing the square root of 50, well, it's, and I've seen you guys kind of struggle with that throughout the year when you had to simplify a radical that was not a perfect square. But 50 is 25 times 2, and you get 5 square roots of 2. But remember what I keep telling you guys about being good test takers is use the multiple choices to help you. R is either 5 or 5 square roots of 2. Those are our only options. And hopefully you guys remember that the square root of 25 is 5. So the square root of 50 can't also be 5. So it's got to be the other one, okay? So just doing that much, you're at a 50-50 chance. But let's take it the last step, which is to find our theta. We do y over x, or sine over cosine, okay? Remember, that's what we have. We have y over x, which is -1, right? So the question is, where on the unit circle do we have a tan value of -1? Well, first of all, what's the denominator? What denominator has tans of 1? Yeah. Plus, you can't get it wrong. Look. Use these to help you. And if this guy's in quadrant 2, so is this guy. So that is 3 pi over 4, which is that. Okay? All right, 25 and 26, such good questions. They go hand in hand. This is where you're going to be looking at a table of values and deciding, there's only 4 choices that you could get. Is it linear, quadratic, exponential, or log? Okay, it's one of those 4. And we'll cover all 4 of them in these 2 questions. The other reason I like going over these so much is because if you remember, there's a part of an FRQ that you have to actually say, what does that represent and why, in your own words. And it's an easy point to get if you just know what words to look for. And I'm going to go over it all with you right now, okay? So before I even look at the table, let's see what the offerings are. They're either offering us exponential or log, okay? So those are the 2 that we're looking for. Now I'm going to go look at the table. And I'm going to see what the x's are doing and what the y's are doing. Inputs, outputs, okay? So taking us, remember, I don't have a calculator. I can see that I'm not adding a same number each time. I multiplied there by 3, right? And maybe I don't know that 15 times 3 is 45, but it is. Carry the 1. And then you could start assuming, because it's going to be one of those 4 types, and there's not like times 3, times 10, whatever. So you can now at this point assume that we're multiplying by 3 the whole way down. Guys, this is called proportional. It's spelled down here, right? Look at it. Okay. Anytime you're multiplying by the same number through either the inputs or output, we call it proportional. That's a word we're looking for as graders when you do it by hand, okay? And I'll come back to that. What's happening with our x's? Add 1, add 1, add 1. What we say for that, and you will say it in all 4 types, this next thing I'm about to say is consecutive, it's down here, equal length, whether it's input or output values. Okay, and I'll come back to that. So those are words that we're looking for. So here's the thing. Every single problem, whether it's linear, quadratic, exponential, or log, will have either the inputs or the outputs say something about consecutive, equal length, input, or output values. The only time that it's on the y's is in a log. Right away, you know that this is a log because it's the x values that are proportional versus the y values, okay? If this was flipped, you would call it an exponential. Logs and exponentials are identical, except the inputs and outputs are flipped. But the words are the same for both. So now that we know it's a log, let's talk about which one. And this is where your English teachers would have a field day with these horribly written sentences. So let's look at them. So we already know the answer is C. So let's start there. F is best modeled by a log. Okay, we got that. And if you look at what comes after that comma, these say the same exact thing except inputs and outputs are flipped. Listen what it says. Because the inputs over consecutive equal length output values are proportional. It's almost like this is like it needs a comma or something. Inputs, blah, 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 are proportional. Inputs are proportional over consecutive equal length output values. Inputs are proportional means a log. Look at this one. Outputs proportional, that would be exponential. It's just a weird sentence. Now, when you write it for the FRQ, you don't have to write it weird like this. All your grader cares about is that you reference inputs and outputs. You have to reference both. You can say X values and Y values, inputs, outputs, and you use the word proportional with either input or output, depending on which type it is, and that consecutive equal length input or output. That guarantees you a point on the FRQ. Easy to kind of guess, or not guess, but find in a multiple choice. Yeah.
What are the input and output values?
Inputs are X's. Outputs are Y's. Always and forever. Okay? So that's log and exponential. Proportional, and then that consecutive equal length values. Okay? 26, same type of question, but look, they're offering us linear or quadratic, so we'll cover the other two. So look what's happening on the x's. And by the way, these just are kind of boring and simple, adding 1, but it could be adding any number as long as it's the same, okay? So plus 5, plus 5, plus 5, that is when we say consecutive equal length input values. So that's that same thing, guys. This is that same little phrase. I don't want to write it again. Consecutive equal length, and of course this is input values, okay? See how it's going to be in every single problem? That little phrase is in all 4 types. Because linear or quadratic will start like this. The x's will always be this, okay? Remember what I said, I'm going to just cover it again. Linear, quadratic, and exponential all have the x values doing the same exact thing, okay? Log is the weird one where this little situation is happening on the outputs. That's the only difference between log and exponential. Okay, now, what's happening with our y's? Well, when we're talking about linear and quadratic, there's no multiplication. There's something called common differences. What are we adding or subtracting as we go through the chart? So, without a calculator, you're going to have to go off to the side somewhere and do a little bit of math. And I'm going up here, right? 64 to 85, so I'm adding 21. 102 minus 85. Do we remember how to borrow and carry and all that stuff? And honestly, that's good enough. Once I see that these are different numbers, I immediately know it's not linear. Okay? So let me explain this. If we get 21 plus 21 plus 1, or minus 5, minus 5, minus 5, minus 5, that's linear. What these are your AROCs. These are your slopes, your rates of change. In a line, they're always going to be the same, right? On any line, I can take any 2 points I want, and do the slope, and I'll always get the same number, right? The same answer. But we didn't get the same one. So guess what? And sometimes we call those first differences. Then we go to second differences. Now, I'm taking a shortcut here because we want to, we're in survival mode. We're fighting for every point in this, rigid amount of time. The minute I know that these are different, as long as I trusted my math, you can rest assured that these should be the same, okay? So I'll just put a few more on here just to prove it to you, even though you didn't have to find all these numbers, okay? So I'm very clearly proving that this is not linear. When I do 21 minus 17, or what are we're going down, so subtracting. That's -4, that's -4, that's -4. Even if you didn't take the time to do that, the minute you saw those were all different, you can pretty much assume that these are the same, because we only have linear or quadratic. Technically, if these were different, you would go to third differences. That would make a cubic. If those were different, you could go to the next fourth differences. That would make a quartic. We don't go that far, okay? You have 4 situations you have to be aware of. So what we just found is that our second differences, although we don't use that word, are the same, meaning that makes it a quadratic. So if those are all the same, linear. If these are all the same, quadratic, okay? That's the only difference. So we know where it's C or D. Now, which one is it? So listen to the differences. C says because the rate of change over consecutive, there's that consecutive equal length input values. That's talking about the x's. So it's saying the rate of change is constant. That's linear. The rate of change, the slopes, is the same. Linear. This is our answer. Because the change in the average rate of change, look, the change in the average rate of change is constant. And then again, over consecutive equal length input values. Okay? So again, this little phrase right here, that is going to be in every single one. The only one that it would say output here, remember, output is when you have a log, but all the other 3 would say input, but that same phrase. And then you can see the differences in all of them. So I'm hoping that helps you guys kind of see the differences in them. Thanks. Okay. And if I went too fast or someone needs more explanation, when I'm done at the end, if anybody needs some one-on-one, wants to talk through something, show you something on the calculator, I'm happy to do it. All you have to do is ask. Hey, 2 more on this set. 27 is one of the problems that we had yesterday. Given f of x and g of x, what are the x coordinates of the points of intersection? Who remembers? Who remembers? How do we do this? What? I didn't hear either of you. I'm sorry. I'm not saying what, like I didn't, like it was P-R-Y? P-O-I. Nope. What did you say, Josh? No, easier than that.
Don't use the plug-in. Set them equal to each other.
Set them equal to each other and solve. Points of intersection, okay? And we had a question similar to that yesterday, all right? On the graph, to go y1, y2, graph them, find the intersection. All right, so setting them equal to each other and solving for x. So let's review how to solve this trig equation. First of all, you want everybody on one side together. So I just subtracted cosine x. And then I have to decide what to do here. And a little teacher trick, and you've seen me do this all year, is sometimes we as students, we look at these math problems that we have to do with words, and it's like, what? How do I solve an equation? Like, what am I doing with words? Well, you probably felt that same way back when you learned letters in math, when you got to Algebra 1. So something I like to do, if I'm stuck or a student's stuck, is kind of think of this as algebra instead. I don't know if this helps, but I'm just going to throw it out there. So maybe if I change that to 2xy minus cosine I called y. How would I solve that one? Maybe that helps you, maybe it doesn't. But for some people, that kind of says, oh yeah, I would factor out the y. GCF, it's a GCF problem. You can have a GCF that's a word, okay? We've seen that a few times, so you just want to have that in like your little tool belt of things that you can think of. So what you're doing is taking out your GCF and dividing the two terms by that, and whatever's left over goes in the parentheses. It's just the reverse of the distributive property. And guys, then I'm just going to take each of these and set them equal to 0 separately, and then use my unit circle knowledge to answer the question. Okay, so where is cosine 0? Sounds like a quadrantal to me. Cosine is 0 up at the top and at the bottom. And never ever should you ever be working on a problem without at some point looking over here. You want to make sure you're like on the right track. And so, I mean, me, if I'm taking this test, I would pause real quick before I go into there and make sure, am I doing this right? I mean, if I would know if I'm doing it wrong for sure if none of my choices had that. And when I look for that, guys, look, there's only one choice that has that, which is a bad question design, so I wouldn't count on that happening. I would bet typically there'd be at least 2 of them in there that have the right answer, but you might get lucky if you're feeling pressed for time. Maybe you feel really good about, you know, your quadrantal knowledge and you don't have to go on to this one. Of course I will. So we have to get sine by itself. So add 1, divide by 2. Add 1, divide by 2. And we want to know where sine is 1/2. What denominator has a y value of 1/2? That would be your 6's. And sine is positive in 1 and 2. 1 and 2. And that makes sense then. Right. Last one in this packet. This is something we talked about like 100 years ago. So I'm fairly certain you might have forgotten. So let me just review this with you. We're given a rational function. We want to know which one of these is true. So just so you know, rational function is a polynomial on top and a polynomial on bottom. Poly on top, poly on bottom. And we did a lot with them back in Unit 1. And so as I glance, just quick glance, I'm seeing a lot of stuff about horizontal, and there's something that's slant asymptote. This has to do with HAs, horizontal asymptotes, which we don't talk about all the time. So let's talk about it. To find out a HA, a horizontal asymptote, all we care about is the first term of the numerator and the first term of the denominator. The rest of it doesn't matter. Kind of like with end behavior, we only care about the first term. First term is very telling. It gives us lots of information. Okay? And so, you know, you're not doing this with us? I'm going to assign that numerator's coefficient A, X. I'm going to call the degree N. This is just so I can explain something. So the A is 2, the B is 1, N is 3, M is 2. So that's what we're looking at. Okay? So if you want to write these down somewhere, feel free. For horizontal asymptotes, if N is less than M, so if my numerator's degree is less than my denominator, like 3 and 4, for example, we would say y equals 0. Always, no matter what, it's going to be y equals 0. Memorization, I don't have a trick for you. Less than 0, I don't know. If it equals, then you look at the A over B. We saw this one a lot back when we were doing these. So if it was a 2 and a 2, exponents, 3 and a 3, 100 and 100, then you would go to the A over B. So if these were both a degree 3, my HA would be y equals 2 over 1, 2 over 1, or 2, okay? And the third and final one, which is what we have going on here, is when N is greater than M, right? That's what we have. 3 is greater than 2, okay? We have none. We don't have an HA. But check for a SA, a slant asymptote. And literally we talked about it for like 5 seconds. But I think you're going to find this is pretty easy to figure out. So if you have the numerator is greater than the denominator, sorry, right now, then you say it has no HA. Well, this says has a slant asymptote. Okay, let's go back to that. Has a HA, has an HA. We know it doesn't have an HA, okay? This one says does not have an HA because the denominator does not have, has nothing to do with this. What does that even mean? I feel like it's made up words. We know it's this answer, and let me tell you how you identify that. It's super, super easy. When the numerator is bigger than the denominator by a difference of 1, then you're going to have a slant asymptote. Since 3 minus 2 is 1, yep, we have an HA. So if it's 100 over 99, we have a SA. We have an SA. If it's 10 over 9, we have an SA. Okay? If it's 5 over 2, we don't have HA or SA. It's got to be a difference of 1. Because when you have a difference of 1, that is called linear. A slant asymptote ends up being a line. Slant asymptote, which is what a line does, like slants, okay? And that's why it's saying something about the quotient of the two polynomials is a linear function, meaning when you subtract the two numbers, you get an exponent of 1. Anytime you have an exponent of 1, you're a line, okay? Lots to have in your brains, right? Let us go to the gold packet now. Everybody, gold packet. So this is where I lost my ever-loving mind on my morning. So these ladies in the front were asking me how my day's been, and I said it's been a little stressful. It's because it actually, like, I truly, this sounds fake, I truly care about you guys. I truly care about how you do on this, because I know you know it, and what we're doing here is just bringing it back to the surface. And when I see people ignoring me, and in my morning classes, I was like, everybody, I want to see everybody typing in the calculator. We're just doing 3 problems. It doesn't take very long. What takes long is me having to keep telling people, we'll wait for you till you're going to pick up your calculator too. You guys should want to do this stuff with me, okay? Especially the calculator stuff. Let's remember all those things that you've been working so hard for all year. Okay, so what are you always going to do when you pick up your calculator? Clear your RAM, okay? If you don't remember how to clear your RAM on the day of the exam, you're in trouble, okay? Because no one's going to help you. The only thing your proctors can do is give you a new calculator because it died, lost its charge, the batteries are dead. You can ask for a new calculator. They can't help you. You can't be like, why am I getting an error? They're going to be like, too bad, that's on you. You have to know how to do it. That's why I know when I say things, you understand what I'm saying. You watch me, you're like, yeah, you press that button. But sometimes you have to do it yourself to really get it in your brain. Trust me on this, okay? So let's do these 3 problems. We cleared our RAM, and I love number 76. It ties into the problem a little bit yesterday that we did that had the pattern with a smiley face or no pattern, appropriate, inappropriate, all that stuff. What we are given is a table of values, okay? Think of this as actual data. This is real information about some word problem we don't know, okay? And that's a table that represents f of x. We want a cubic regression to model these data, okay? And then we're going to find f of 5 of the model. Now let me put that in English. Again, scientists come up with some information. We've seen all these dumb questions about white-tailed deer and, ducks or whatever. There's always some word problem. Scientists are doing something. They hand over the information to the math people, and we take it from there. So we're the math people that say, okay, we're going to find a cubic model that models this as closely as we can. So what we get in the calculator is the model. It's going to try and match this as best as possible. So anytime you're given a table of values, we go to stat, enter, list 1, list 2. So everyone should be typing in list 1 and list 2. Remember, list 1 is your x's, 1, 3, 5, 7, 8.
I can see it down there. I'll see it later.
Okay. It's right here. So.
Well, yeah, I know. I'm just saying that. Like,
Okay.
in the steps where we need to see it.
Yep. I will fix it. Say it again. I can't figure it out. I know it's in the blue, right? Oh, do I have to hold the button?
No. You gotta press second and then you gotta keep it. Yeah. Oh yeah, that's what that is.
I love it when the students teach the teacher. I love it.
My tattoo has the same thing but down here.
I've been wanting to do that for years. This is why, if you notice the first half of the year, I didn't even use the nicer one. I used like those. Not that they're bad, but this is a lot faster and stuff like that because I couldn't make it show up very well. Hey, thanks, guys. I'll forget, but I'll try to remember. Okay, so you put your... Yep.
Write it down.
I know, yeah. Now, if I do it a few times, I'll remember it. That's why I want you guys to do things. Okay, list 1, list 2. Where do I hit now? Stat. Kaylin. Over to calc. And you're told what type of model. It says cubic. Okay? So find it. Cubic regression is cubic reg, number 6. And you want to store it. Okay? Alpha, trace, enter, enter, enter. Do we need the equation? Sure don't. Could get a question where they want the A, B, C, or D. We had a question like that on an FRQ where you needed the A and the B of something or whatever. That was where you would get it from. Do we need to look at the graph? Nope. We want to look at the table of values. We want F of 5 of the table. So I go to the table, and you go down to 5, and you can see that would be this one. Common mistake that students make on this question is they're like, oh, I know what they're doing. They're making sure I know that 5 is the X value, and they'll pick that one, okay? And you can see that choice is there. It's not asking for F of 5 of that. It wants of the model. Store it, alpha, trace, enter. So stat, calc, number 6, enter, 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 where it says store, alpha, trace, enter. Okay? Easy problem, guys. Easy. If you have a table of values, you use your stat. Okay? And the next one, we don't have a table of values. We actually have a polynomial and a window. That should kind of give you an idea. Rate of people entering a country music concert at a large arena is modeled by this function. R of t is measured in people per hour, and t is measured in hours, blah, 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 blah. Based on the model, at what value of t, you can see t equals something, does the rate of people entering the arena change from increasing to decreasing? They're speaking in code. So I have already hinted to you, clear your RAM, I have already hinted to you that, table of values, you go to stat. I think we all know, if you have the actual equation, we go to y equals. And we're going to type that in. But what does increasing to decreasing mean on a graph? What is that code for? There's this very special word that translates. Okay, that's true. A turning point, a point of inflection. There's another special word. What is it? Yes. Okay. I don't want to just tell you. I want to see if you guys can read it. So if I have this curvy graph, so here I'm increasing, right? Increasing. And then somewhere around here, I change to decreasing. What is that called? It's called a max. It's a max. And this guy would be amen. Okay? So you guys were all saying really good things, okay? What we're looking for here is a max. And I'll explain to you again in another place when we get to it why that is so. So everybody should be typing this in. So guys, anytime you have to type an equation in and they're giving you a window, change your window. So t, time, is like your x-axis, right? So when I go to window, I'm going to change my x min, 0 to 5. Now, do I need to change my y's? Sometimes you do, sometimes you don't. Sometimes I won't even think about it, and I'll go to graph it, and I can't see what I need, so you can always go back to your window. But I tend to not make too many changes until I know I need to. And in this graph, you won't need it. Now, we have to find the maximum, and remember I said that's what we're doing here, The maximum, this is a pretty flat. Do I have to keep doing that every time are you serious? I'm going to have to learn how to do this because I have to do it a lot of times. Every time I clear my RAM, it goes back. Okay, this is a pretty, it's definitely concave down, but where is the max, right? Do you guys see my pencil? It's somewhere up here, right? But what's nice is your calculator is pretty smart. It'll find it for us. And so, again, how could I know what they meant by increasing to decreasing? Well, usually when we have to find something on a graph, it's in our calc menu. No, always it's in there. Is it a 0, a min, max, intersection? Makes sense that maximum, okay? So number 4, and this is where you do left bound, right bound guess. And remember, your calculator always drops the cursor right in the middle. If that's a good place, that's fine. So here's the thing. The max is somewhere between my hands. That's good enough for the calculator. You don't have to get this close. You don't want to miss it, okay? You can be pretty far apart. Like I can hit enter here, arrow over somewhere over here. See, I'm giving myself plenty of room for my calculator to find the max somewhere in there. It does not have to be close together. And then enter. Maximum is 3.204. It even says it, max, at the bottom. Another student said, well, I didn't do that. I went to the table of values, and I looked at the y values. Increasing, increasing, increasing. Somewhere between 3 and 4, it started decreasing. So they were able to find that answer without even doing the max. Great. That's a wonderful method until they give you something like this as another choice, right? How would you know which one, all right? What did you say? I don't know how you do that. Until you found the matching answer? Oh. I'm going to ask you how you did that later because I don't know what you're talking about. I understand it, but I don't know how to do it. All right? So, given a table of values, we use stat. Given the equation, we go to y equals. Okay? Last question. We had a question about geometric sequences yesterday, so we kind of touched on them. They're giving us g of 5 is 18, g of 8 is that. What is g of 12? So, basically, they're giving us the 5th number is 18. The 8th number is 60.75. What they want to know is what is the 12th number. Guess what? Yes, I heard somebody say stat. This is a table of values. Where's the table? Oh, we don't really have to have a table of values. We don't have to have a table. We have to have x's and y's. Sometimes we have a whole bunch. As long as we have 2, we have a table of values. So clearing your RAM, always, and then going to stat, edit, 5 and 8 are list 1. 18 and 60.75 are list 2. What? Wait, what?
Like, because there's trying to find the 12th one.
Well, we're not going to put, if you put 12 in and leave this blank, you'll get an error. You don't put that in the table of values. Okay? I'm just saying, I don't think it would work. You can try it. I don't think it does. But as long as we have the 2, that's good enough. But here's the thing. We go to stat, calc. Which one is it? Remember I said you're always going to be given one? I lied. Okay. You just have to know. You just have to. Okay. You have. See if you get the same answer as me though. Geometric sequences. Do you remember yesterday we saw the graph of one? It was already graphed. Remember we pulled the points off the graph? What type of graph is that? Remember it looked like this? Who said that? Good job. Exponential. Know it. Geometric sequences are always exponential. Something you have to know. And it's 0. 0 is EXP. Enter, enter, enter. Are we going to store it? Michelle, how do I store it? Tell me the buttons. Alpha trace, enter. Okay.
What's the number?
I don't. One second. I don't need the equation, but if I needed the A and the B or the equation, here it is. I'm going to go to the table. So table down to 12, and it's 307, blah, blah, blah. Okay?
Okay, I gave the
Yeah, I didn't think it would work. Okay? Know these things. You know you're going to have intersections somewhere in here. You might have zeros. Put it in, go to your calc, left, right, down, all that stuff. You're going to use it all the time. And we've been using it all year. So that's it for today. If you don't need me for anything, you can pack your folders up, put them neatly over there. If you want me to go over any of that with you, one-on-one, I'm more than happy to. After we take the AP exam? After we take the AP exam, we hang out. We hang out.
You said you bring like your.
I was thinking of bringing my what's it called? Oculus. I'm really good at Beat Saber. I don't. Is it Saver or Saver? B. Oh, I've been saying it wrong. I don't want to brag because it's not very nice to brag. But I'm gonna have to brag because I'm recording this. Oh, a challenge accepted, my friend.
I should bring my Xbox to be able to play Halo.
So wait, I don't know if that's